Welcome everyone. In this video lecture, we will think about the capacitances present in NMOS, PMOS and CMOS inverter. So first of all, we will draw a NMOS. Okay. So first I am drawing the NMOS. Okay. So this one is our NMOS in which this one is our body terminal and this one is our say drain in, gate in and source it. Okay, so mainly this end is connected source and this bulk. Okay, clear. So in this case there are some capacitances. Okay, we can say the parasitic capacitances like this. One capacitance is here, one capacitance is here. Okay, or you you can connect to this bulk. Okay, four capacitances I have made. So one can write this as a this index gate. So we can write it CGD. Okay, CGD of N gate to drain capacitances. This should be CGS to N gate to source, and this one is our drain. Okay, drain and bulk. Drain and bulk of N, and this one is very simply what source and bulk. Okay, substrate. So this one is our four capacitances. Okay, now if we go for the PMOS. Okay, so once again I am making the PMOS. Okay, so in PMOS the bulk is connected to source also, but it is connected to supply. Most of the time this one is connected to supply. So I'm making like this. Okay, so this end is our what gate, this end is our source, and this end is our drain. Okay, so here again what we can do, one capacitances, one capacitance here, one capacitor here. Okay, means I'm just showing how to draw the capacitor. Okay, here you can connect, or you can connect like this. Okay, so this one is again CGS of PMOS because this one is our PMOS. Okay, CGD of gate and drain, GDP. Okay, and this one is our C drain and bulk, drain and bulk of P, and this one is our CSBP. Okay, so this one is our NMOS and this one is our PMOS. Okay, now if we go for the what we can say a CMOS inverter. Okay, for the CMOS inverter we have to take both the NMOS and PMOS in a circuit. So first I am drawing the CMOS inverter. Okay, so for the CMOS inverter, first there will be a PMOS. Okay, so I'm just doing the PMOS. Okay, in which the substrate is there and it is connected to VDD, the PMOS, and one NMOS. So you can make like this, and this one is will be like this. Connect here. The source terminal of NMOS is connected to ground, and source terminal of PMOS is connected to VDD. I am writing this as a source terminal, gate of, better to write gate of N, gate of P, source of P, drain of P, drain of N, and this one is the source of N. Okay, and these two in is connected in a CMOS inverter. Okay, and we are taking some output here. Okay, and if it is a cascaded with other one, okay, before that I am just putting one capacitor. Say I am saying C internal. Okay, and along with that we are just connected with another inverter. Okay, or better to make the similar design as that of the NMOS. Okay, and it is connected. So there is just some gate capacitances, gate overlap capacitances, and it's connected like this. Okay, so what are the different capacitances present here that we are just giving a transient input. Okay, time domain input. Clear? This was a symmetrical one. Okay, so now you have to analyze the different capacitances. Okay, so the very first capacitance that we can say there is there will be a capacitance here, that is our C gate source and P. Okay, very similar to the previous one. Okay, once more capacitor, this capacitor is our C gate and drain of P, gate terminal and drain terminal. Okay, now we can make like this one capacitor here, or you can directly connect here. Okay, or you can connect here, same thing. Okay, this is all a wire. Okay, so this should be C S B of B. Okay, and once again one more capacitance will be there, which we have to connect like this. Okay, so this one is our C D B of B. Okay, right, C D B of PMOS. Okay, these are the four capacitances. The another one is our simply another one will be like C get and drain of N. Okay, get and drain of N. Then we can write this capacitor C get and source of N. Then one capacitance will be there. You can make like this, or you can directly connect here. Same thing. C source and bulk. source and bulk of N, and one more capacitor we can say this capacitor. This capacitor is our C D, drain and bulk of N. So there are four capacitor here, four capacitor here, one C internal capacitor that I will tell, because this one is the capacitance, we can say the interconnect capacitance, okay, or lumped interconnect capacitances, okay. So I'm just saying the different capacitors, what are the different capacitance we are using. C I N T, okay. C I N T is the lumped interconnect capacitance, okay, between the cascading between the one inverter and one more inverter, we can say, or an amplifier stage, okay. So that is our CINT, which represents the parasitic capacitances. This one is the parasitic capacitances which contributes the contribution for the metal connection to two inverter, metal connection to two inverter, okay. Then after, there is one more capacitances, say the CG. This one is one more we have added, like CG. Okay, CG is the thin oxide capacitances. Okay, thin oxide capacitance. Okay, over the gate area. Thin oxide capacitance over the gate area. Okay, now this one is CGD, and CGS is primarily this CGD. Okay, get to drain capacitances, and CGS. This one is again get to drain capacitances. Get to drain capacitances. Okay, and this one is our get to source capacitances. Okay, and these capacitances, these two, okay, these two capacitances, CGD and CGS, the parasitic capacitance, is primarily due to the gate overlap with diffusion. This one is due to gate overlap with the diffusion. We can write it. Yeah. These capacitances, this parasitic, these, okay, I'm writing these parasitic capacitances arises due to gate overlap with diffusion. Okay, CGS, CGD, and CGS. Clear? Now, next one is our the other. Okay, so now these are the subcapacitances, and drain to bulk P, source to bulk P, all we have written. Now to analyze the voltage waveform, the total capacitances we can write at the load, okay. Total capacitances at the load we can write C load, okay. If what first I can write the total overlap or total load capacitances, so what we can write C G S P plus C G T P, first I am writing for these two, plus C S B of P plus C T B of P, all four capacitances, plus C G D of N plus C G S of N plus C D B, okay, drain and bulk of N plus C D B, okay, drain, okay, digital C S B of N plus C intern plus C G. Okay, all 10 capacitors 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all 10 capacitances. But the major role in the analyzing the voltage waveform is contributed by these four capacitors 1, 2, 3, 4, 5. Excuse me. 1, 2, 3, 4, 5, 6. These six capacitances like CGDP, CGDP, I will tell why. CGDP, CGDN, okay. Then after CDBN, DBN, okay, CDBP, CDBP, okay. Why we are not considering this one, that I will tell you. So basically, in particular, we can say the source CSB, okay, CSB, CSB of N, source to bulk of N, and CSB, source of bulk of P, have no effect, have no effect on the transient behavior. Yeah, because source to substrate voltage, source to substrate voltage of of both the transistors, both the transistors are always zero. Okay, but we can see that the CSBN. So this one is our CSBN. So this end is connected to ground 0 volt. Okay, and this one is also source terminal, and this source and bulk is having the same connection. It is connected to the 0 volt. Okay, and if you look for the CSB, CSB of P, okay, CSB of P, one end is connected to VDD, okay, source VDD and VDD. Okay, so the effective voltage they will be, this voltage will be 0. Okay, the tiny wave because source substrate voltage of both the transistor are always 0. So we have to not consider the CSB. CSB, where is CSB? Okay, CSB of P we have to not consider, and CSB of N we have to not consider. In addition to that, the other two capacitances CGS of N and CGS of P are also not included, are also not included because the input in node N, because the input node, because they are connected to input, because the input node and the ground connection, input net and ground connection in CGSN, CGSN, and in this CGSP input node and the VDD supply. Okay, because the input node is connected to ground and the input node of the CGSP are connected to the supply. Okay, so the capacitors CGSN and CGP are also noted because they are connected between the input node and the ground. Okay, an input node with the supply. So we have to note considered. So mainly the C load will be contributed by these six capacitances. So the C load capacitances, C load capacitances get to drain of N plus C get to drain of P plus C drain to bulk of N plus C drain to bulk of P plus C in T plus CG. Okay, means CGDN, CGDN, CGDP, CDBN, CDBN, CDP, CDBP plus C in T plus CG. So these are the capacitance which contributed a lot during the transient analysis. This is all about the capacitances in a NMOS inverter. So here also we can write in C NMOS the total capacitance will be CGDN plus CDBN plus the other two CGSN plus CSBN. Okay, and for the CPMOS it should be CGSP plus CSBP plus CGDP plus CDP. Okay, so this one is an important concept. Okay, no need to remember. First, you have to draw the circuit, and then you can say this one is the capacitance across this get to drain. Okay, we have to know which is get to drain or no. Okay, similarly for this one, for current that we have written, and for the inverter stages. Okay, for the total load one, we have to consider only these four. Okay, clear? So this is all about the capacitances in a NMOS, PMOS, and CMOS inverter. So thank you for watching this video.